Hello, welcome to the channel, Fabricating Firewood. My name is Matt. Today I'm going to be welding up some feet or fork pockets base for the firewood bundler. I have 3x8 rectangular tubing. It's 1/8 inch thick, so it should be able to take a beating, and it's going to make a nice stable base or platform for the firewood bundler so I can move it around the yard with the tractor with the forks on it. I've got the top pretty much done, except for the front part and the part that goes in towards the bundling, the business end of it. But I'm going to wait to do that until I get this squared and set up, and then I'm going to weld a temporary piece in between the end that's exactly the dimension where it's bowed in a little bit. Instead of pounding on it, I'm going to weld just a temporary spacer or whatever that you want to call it in there, so that when I go to weld it together, it's going to be nice and square. So first thing I'm going to do is grind off these corners because they're pretty sharp. I'll get into laying it on the table and getting it to a point where it's going to be the finished product, and then I will start tack welding the frame structure for the bottom. I'm going to have the seam facing the opposite directions or together. I want them kind of symmetric. The finished dimensions of these are 3x8 ish. It's not actually 8 inches, it's just under 8 inches and just over 3 inches, so it's whatever. But finished length is 31¼ inches. That's going to be the front to back bundler here, feet for the base. The minimum inner dimension of my forks is 20.5, so I'm going to make these 20 inches apart. And the way I'm going to do it, since there's plenty of room on the table, is I'm going to square this up to the table perfectly, and then I'm going to go 20 inches out. That way I know it's not going to be crooked. And the dimension I have to get is 20 inches from inside to inside. Just basically clamping something to the face of this so that I can bring it all the way and get it square to the front of the table. Okay, so that's 20 inches. It's up against 20 inches, and it's up against the face. And since this tubing is not perfectly square as far as this whole face right here is kind of curved, because I mean it is what it is. You want to make sure that you measure. Like if I'm going to measure the top of this, it's going to hit this radius, so I want to measure right in the middle to get it consistent and square. Now I'll check for square. 47 and just over 3/8. Tape measure does want to hold on that radius. 47 and just over 3/8. Okay, this thing is perfectly square. So now, before I go bumping it, I'm going to tack weld it to the table so it's nice and square. Okay, so I've got this 1.5 inches by 1.5 inches. I'm going to weld it 2 inches in onto the ground, and then back there it's going to be all the way across the back, and then I'm going to have 2 of them on the top. So the outer ones be on the bottom, the middle ones will be on the top, and that'll give it some support so it doesn't basically flex. All right. One last measurement. 20 inches. 20 inches. So that's going to give me a perfect base to start welding on without having to worry about things warping up. So now this, I'm going to have to go to the center as well because it's bowed out. That is 19 and just over 3/4. Okay, got cross braces cut. They are cut at 19 and just over 3/4 inch. I'm going to put a nice 45-degree chamfer on this for welding. This is why you want to tack weld everything down to the table, because it's 100% square, accurate, and then when you go to put a piece that's a little bit longer, you cut this down instead of having to accidentally move this. I'll clamp this down. And it'll be sitting on this plate and then just butted right up against it, minus about about a quarter for a weld. I don't want to put it right on the edge, because then I won't get a good bead. So let's go from the inside 1 3/4. That'll leave me a 1/4 inch bead. And this really does not have to be this exact. I could just put it in there and do it, but my WebMD undiagnosed OCD, where everything has to be just so. If you can't do it right the first time, ain't worth doing. So I'm going to clamp that down because it moves a little bit too much for my taste. So I'll get it right at the 1 3/4 and then clamp it. So I'm going to tack weld this side because I know it's down where it needs to be, and then I'm going to clamp the other side. Make sure this did not move. 10, 10. Just basically flush this up to the plate. Give me some symmetric fill. All right. Good. 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 Tack. When you're welding, before you go welding, you want to make sure that this is not spun around or twisted. Kink up your line. So you get it near, and that's pretty damn near. Clamp one side, verify, get it close, and verify. There we go. 10, 10. So, got the plate inset 10 inches, the support perfectly aligned with it, ready for tack. Now you're probably thinking to yourself, that is not required. All this is not required. And it's not. I agree. I concur. However, I can't remember who I saw that had their bundler that they bought. They paid for it. I think it might have been either Keith or Kevin's Cool Tools. I can't remember which it is. I think he bought a bundler, and as he was moving it or something, something hit it, and it bent it some, skewed it, as it were. And I want to avoid that. I want this thing to fall over, be dropped off of a pallet fork, off the back of a truck, and maintain its shape. And I'm pretty sure this is going to do the job. So I'm going to do a quick square measurement, make sure that it's still square, and then I'm going to finish these welds up, and then I'm going to break the weld tabs off 47 3/8. 47 3/8. That is what I am talking about. So I'm going to put all my welding garb on, and then I'm going to start welding. And I like to weld just like you put lug nuts on. I'm not going to weld all this up and then weld all this up and then weld all this up. I'm basically going to do this face, that face, this face, this face. I'm just going to keep bouncing around to mitigate any heat warpage, because I could weld it and it could warp under tension. And as soon as I break these tabs off that I have around it, it could just go boing and spring up. So I'm going to try and mitigate that by moving around. And if you've seen the blue shipping container, it's got a steel commercial man door on it, and that was welding, I think it's 12 gauge steel. So I welded a man door all the way around it, and that took me 8 hours to weld, because I did not want any of the opening right here, literally, and the cutout, and the thinner, I think probably 16 gauge steel frame. I did not want it to warp. Actually, I welded a 1/4 inch plate, 6 inch by 1/4 inch plate, all the way around the border of the door, and that took me just as long. So I basically tacked it on and then inserted it, made sure everything was square, and then I just basically kept bouncing all over the place. Just 1 inch long welds, and inside and outside. It took me 8 hours to weld that. And it's perfectly square and plumb. I am good to go. Time to sweat. Can't even get this thing on because it's sticking to me already. Ugh. Oh, that's miserable. Oh. I'll go to E5 on my ProMig 175. Oh, so that I can ensure that I'm penetrating into that 1/8 inch steel and not just welding on top of it. Not worried about this too much because I've got to get a 45-degree chamfer on it to penetrate. We'll see how that does. Ooh, look at that, it's just barely hanging on. Now what I did there was, since we've got a radius on this, right, there is a good 1/4 inch gap in between here and the edge of the 45-degree chamfer, and if I were to just basically weld, it would just burn right through this piece and just slag in. So basically I got to do a quick spot weld bead to get it to get a good connection. And what you're doing is you're watching the bead, the glow, pull up, and as soon as it pulls up, pull, like P-O-O-L, pull. As soon as it pulls up to a point where it makes the connection, you hear that cracking? That's basically one of the tacks breaking. So once you see the pool of weld basically spread out, that's when you stop, and then you let it cool, and as soon as it dies down and it's no longer red, you're ready to do the next one. You're just basically building it up. The greater the distance, the longer you have to wait in between each bead. This one went quick because it had a close, it was closer. This one's got a big gap in it as well, so I'll have to go slow. Another thing, you don't want to point into the thinner piece that'll blow through. You want to point into the solid piece so that it basically hits the solid piece and starts pooling and flows into the thinner piece. They're the same thickness, but this has got a 45-degree chamfer in it, so it's actually thinner. Stacking dimes. Now this one over here, actually move over here. So these lower ones, they're butted right up against the flat, so I can go relatively quick on it. Make sure I'm not kinked. And I'm doing a stitch weld where I'm basically just rocking it back and forth. concentrating most of the weld on the solid piece as opposed to the piece with the 45-degree chamfer on it. I wish this welder had a function that allowed me to keep the gas on for a little longer so I could shield the weld until it cools, but it does not, which is what you do with TIG welding. When you're TIG welding and you got the nozzle, and let's say this is the rod, you're basically heating up the material and then feeding it, and you're basically walking it towards it, right? And then once you're done with your weld, you back down on the voltage, and then you keep the nozzle on it over the area, and it keeps it popped again. It keeps the gases flowing over the weld to prevent it from getting oxygen to it before it actually has time to cool. For some reason, I keep wanting to say dry, like it's a caulking or something. All right, let's do this one. Another problem you'll have is wind. You don't want any airflow going across it because it will blow the shielding gas. If the wind is stronger than the shielding gas or from a fan or whatever, you'll actually blow the shielding gas away and your weld will look like shit. You also want to, before you go welding, like in this little corner where this tack block is, to keep this down to the table, you want to make sure that you have enough travel, because right now it's hitting. If I were to basically go straight down like this, the nozzle would hit the thing, so I have to basically come in at a different angle and do the complete travel to make sure that you have the complete travel so it doesn't hit something and stop your weld. Slag buildup can also inhibit your gas flow. Another problem you run into is when you're hitting an existing weld. So at each corner of these bars, I have tack welds, about a 1/4 inch by 3/16 tack weld. And as soon as you hit it, it wants to build up quicker. So you got to kind of, and it's hard to explain on what you got to do, but basically you got to melt it down and push through it, because if not, it'll be a big ball of steel. It'll look like garbage. Okay, so the battery died while I was welding. I got all the welds done, all 3 sides. I verified that. And I went ahead and knocked off all of the tacked on tabs and ground them down so they're ready to use again. This one that was right here, the crackling that we heard while I was welding, it's basically a tack weld breaking. So this one snapped off, right? You can see it doesn't penetrate very well when you're just tacking it. And the one that was over here, right here, also snapped off. But I mean, it's solid. The whole thing was held down by clamps and whatnot. But that will happen. So what I've done is I popped off all of the tabs. I'm going to finish grinding this one down, get it ready for the next time I need to use it to tack something down, and then I'm going to flip this over and weld the bottom of each one of these cross braces. Let me grind this part here. When you first start welding on a project, you want to make sure that you pick equivalent materials to get your weld settings correct, or weld on a spot that you're going to not see constantly, because you got to take pride in your welds. So back there in the corner there was a piece of wire sticking off, and that's where I last adjusted it. So that was close. So what makes it nice about having a shop instead of a shipping container is it's all metal, so you can stick the camera pretty much anywhere you want to. That is the base. That's how you do it. Doesn't rock. Means it's nice and square, nice and flat. So now I have to get this welded to this. So in order to do that, I'm going to go ahead and tack that temporary brace that I had mentioned earlier. So I have to get the dimension between here and then cut a piece and put it in between here and here so that it's perfectly square. Right now we're at 37 1/4, and here it's 37 1/4, slightly proud. So I'll cut a piece that's 37 1/4, and I'll weld it about 4 to 6 inches back, and that gives me a nice stable square to work with. So this should fit right in here. Yep, look at that. Look at that. I'm going to come in 4 inches from the end. I mean, that is just, it's just like perfect. I like these right here because you can use just standard galvanized pipe or black pipe, and you can cut it to the length that you need it to be at. When you get good enough, you can tell the difference in the sound of what material you're on. The lower tone was on the thicker, and the higher tone was on the thinner. So it goes rah, rah, so you can tell if you're, if you're too much on the thicker and not enough on the thinner, and then you just go back and forth until you get it centered by sound. So I'm going to start out on the thinner and then the thicker, so you can tell the difference. So I'll go back and forth, starting on the thinner. So it's got to be centered left and right, flush against the back. 2 proud 1/4, 2 1/4 proud. And right now I'm just getting an eyeball of where I need to have the weld. So I need a longer piece. I need to build this up so that it's flat. So that gives me an idea of where to weld this part here, get the proper distance, and then well, I've got the parts already, but it'll allow me to know where I'm going to put the verticals once I get those welded on. Now the problem I'm having here is that there's a weld right under this, so this is sitting a little high. So I'm going to flip this over real quick, waste the time I just spent squaring it, flip it over, and then grind the weld flat so that it actually sits on the tubing and not the weld. Okay, so I'm relatively certain that's flat enough. Now I gotta start over on my adjustment. I'm gonna get the front and back of this level with the back of the weld table. Now I'm going to make sure it's lined up still. Now I'm going to clamp that down. And I'm clamping this right in the middle of the rectangular tube because that's the high point. I see a gap here and a gap there, and if it's clamped in the middle at the high point, it should be good. So one last measurement. 1 1/4 proud, 2 1/4 proud. So since this is going to be open, I'm going to inset this or outset this a little bit. I'm going to cut a plate out of this and then weld this to the front. I'm going to cut it to the width of the 1.5 inch, and then I'm not going to be able to cut the other 1.5 inch because I'm not going to be able to get a little piece in my my cutter, but I will tack weld this to the face so that this is closed and not going to take a slice off of me or anybody else. And I'll do that for both sides. And then once that's done, I can actually bring this out, this piece out, so that it's flush with that, so that it looks like just one piece. And this is just for aesthetics, to make it look good. And to keep me from taking a slice out of myself. This is where you get sunburns. Let's go ahead and clamp this upwards. That way it's got something to sit on when I tack weld it. So I'm going to turn the fan off, put my garb on, weld this completely around on both sides so that it's enclosed, and that will give me a nice surface to come up right up to it and get me a nice 90 in it. Since this is not a heavy duty weld, I'm not worried about it burning through my t-shirt, but I don't want to burn my arms or get a sunburn on them. Way too hot. And the D4.5. See how this does taking this off. It's a lot faster than changing it out to a cutting wheel. So there's the problem. You don't want to have your ear open because you'll take a piece of slag in your ear and that sucks. You can't get that thing out quick enough, if you can get it out at all. Now I gotta grind this weld down to make it look good. Then I bring this guide out to the edge on both so that it's lined up. Take this, bring it out to the edge so that it is lined up. Okay, so now I've got this part centered on top of the base, and I've got this part that goes across that's going to allow me to line this up perfectly with the front of it, so I can basically clamp this down, clamp this down, and then from there I can weld it. And since this one is the one that's touching, I'll go ahead and clamp it first. Okay, so now this is clamped to this, to this, to the base. Now I've got to see if I have a clamp big enough to clamp these down, which I do not. So I'm gonna see if I can't trade some clamps out. And I'm pulling this whole structure down to the base because it was up a little bit by about just under a quarter. Get that kind of in the center. And one last thing that I can do to ensure that this is nice and flush and square is get one more piece, bring it across the front, and then clamp it to the front. And I can tell right now that this is in a little bit and that is out a little bit. So I'm going to clamp it in the general area of this, as long as I have some clamps that'll fit. Okay, so now I got to make sure that this is up against the front of the plate. So I'm clamping to clamping to clamps. Okay, so that's clamped, that's clamped. Now the problem I'm seeing is that this is straight and this sticks out just a little bit. So best I can hope for is parallel, because I don't want these sticking out too far. Okay, before I go unclamping things, got to think this out. So I've got 3 sides of it done. I'm assuming that as soon as I raise this, it's going to want to pop up a little bit. So I'm going to go weld those sides as well. Get these final welds done. Hope is not a solid strategy. But I'm hoping that since I've got everything clamped down, and that since everything's pretty much welded, that I have good possibility of this being, you know, not bent up a little bit. If it is, not that big of a deal, because I'm going to cut all the verticals the same length exactly. And I'll start back there on that corner. I'll start welding to the base first, because once the base is welded, then I can basically put the top part onto it and get the you know, these three sides done, and then I can basically just pull this down if I need to. But for now, I'm going to mark where the verticals need to be before I unclamp this. Need to find a small piece that's easy to hold. This will do. So I'm going to have a vertical right here. So it'll be in this general area right here. And then right here. And then right here. And then right here. Same with back here. And again, this is just giving me a general idea of where the verticals are going to need to be before I go on clamping this. Thinking maybe that since the base, the rectangular tubing is kind of curved a little bit, it's not perfectly square all the way around, that I might have an issue getting the verticals completely vertical, because it'll want to slope down, because it's pointing up and down, and as it goes this way, it basically curves like that. It's got a crown in the middle, essentially. So I wonder if I should weld it on the floor with this facing up and then this facing up, and just cut them two sides. That way I know that, because this is flat, this metal base plate in the container is pretty flat. If I had a longer weld table, I could do it on the table, but I don't think I have enough room. So I need to cut 4, or 2 for each side, so that'll be 4 total. 4 37-inch pieces for the front, 4 35.5-inch pieces for the rear. These 2 pieces are going to be welded here. But before I do that, I have to weld the verticals, cut this temporary brace out, then I can weld them on there. Okay, I'm going to tack weld this brace on the bottom, and then finish weld these 90s. So what I'll have enough to do is cut these 237, 235, 35 for the back, 37 for the front, and then I have plenty of those thinner wall ones that I can do on the inside. That way it'll still have the 4, and then the front to back, I can use plenty of those. I got plenty of those. I just don't have enough of this 1.5 inch to put 8 of them on there. I'm going to cut the 37-inch piece and then line it up, cut another 37-inch piece, and then start on the 35-inch piece. Now I got to pull these off, put them up, put the verticals on, chamfer 45, clean them up, get them ready to tack. Put these away so I don't lose them. Like so. And I do see a problem. I'm pretty sure the weld on the back of this, yep, I need to grind that down so that it sits flat. That's nice and flat. And ready to weld. All right, so 35-inch pieces first. So I will measure wherever my tape measure is. outside of this. So 35 and 11/16. 35, 11/16. So what I need to do, I need to center these two verticals on the back at 35 and 11/16 inch wide. It's centered on the top portion, and I can use my square to make sure that they're square. Then I can basically tack weld them to this base. Let me check something real quick. Make sure that my theory worked. From the inside, or the outside to outside is 35 and 1/16. From the outside to the outside is, hey, 35 and 1/16. So now I got to do is basically just center this eyeballed, because it's like right on the edge of the radius of the steel. That's a little bit too much. All right. Now, where's my 37-inch piece to see if that brought it in to where I can just weld it as it sits. And it's looking good. So I'm going to take a longer piece, if I have one. Yep, got one over there. I'm going to clamp it to this, run it short to here, set this on top of it so that it gives me the 37 inches. There we go. Okay, so that's a little high, even though it's clamped to the bottom of this, because it's sticking up over here by about a 1/4 inch. I am 2.5 in. I'm going to confirm that before I go welding. Yep, 2.5 in. This is a little high, but then again, it's clamped to this, so it's most likely because this is the corner seam stuff and this is the middle seam stuff, so it's probably not the same exact dimension, so it's going to be a little bit sticking up. So I just have to make sure that I'm pretty much at the right amount sticking up before I tack weld it here. Yeah, it's a bundler. It's a firewood bundler. It's a firewood bundler. That's all it is. It's a bundler. This weld's probably not going to turn out great because of the amount of wind coming through here. So I can shield it with my glove. Nope. That looks like shit. That's a little bit better. So now I'll do the same thing to this side. What I'm gonna do, bring this up here and put it flush so that it's basically this direction flat instead of guessing like I did last time. This direction nice and flat because this is now parallel. Set the whole assembly on top of the support. Do the same thing with this. Scooch it over to 1 inch or 2.5 inches. Make sure I'm not over a hole and clamp it tight. So now I know it's good this way and it's good this way. But the most it might have is a little bit of a twist, but I just can feel that that's nice and parallel, so that's good. And I'm ready to tack. So I'm going to keep these supports on there because I can always push them down. I'm going to line the base plate up again. Center it. So 32 and 3/16. Let's check for square-ish. 56 and just under 3/16. 56 and 1/8. So I would say that's good enough for government work. For a firewood bundler. Now I want to lift this up without breaking the tack welds. So first, just want to slide it this way. we go. Boom. I dare not slide it around for fear of breaking the tack welds, so I am going to weld it in place, and then I can turn it around so it's more narrow so I can get through. But that's going to require me to weld it bouncing all over the place, which, you know, is what it is. I'll crank this up to D or E. Okay. Round. 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 All right, just want to make sure I got all my welds. And I'll tell you what, this thing is freaking solid. I don't believe that I'm going to need to do any more than this. I mean, this thing is like, it ain't going nowhere. So even though I cut those at 35 and 37, the smaller pieces, I may not even use those. And this is what I'm talking about, the pieces right here. I mean, these bad boys are, this thing is solid. If anything, I might use the front 37-inch ones because, you know, this is going to have a little more weight on it. I don't know. I'll finish this out, put it together, and then if it needs that extra support, then I'll go ahead and weld those in, or if I have extra time. Because it is currently almost 6 o'clock. So I'm getting to that point of where fatigue is kicking in and affecting the brain. So I think what I'll do is, while I'm here, just slap the rotator and the back plate. Oh, that feels good. Onto the shaft, just to see how that works, see how it looks, and then that'll give me an idea of where I need to put the pillow blocks for the crank, and they'll give me some good visualization to sit on the recliner sipping some bourbon. And the reason one of the reasons why I wanted to put the extra bracing is because forks are going to be in here, but I think this completely solves the problem of the forks bending anything, because it's not going to. I mean, the top and the outside and the top support is pretty sturdy. This thing isn't going anywhere. I don't know. We'll see. Let's see how this looks. Yeah. Oh. Thing's a beast. That's where I wrote it down right there. 40.25, but 41.5 is where I landed today. And I wrote it on the front of here because that's where I would be looking. However, I didn't consider that, yeah, it's 41.5. I didn't consider that that wouldn't be on when I was trying to figure out the dimensions. So this mounting plate has two of the spacers with two of the grub screws on it, so it's not just relying on one to hold it. So I've got a good inch, about 3/4 of an inch of play to get this lined up with the sprocket wherever I want it. I did realize one thing just now. It might create a problem. I put that chain, look how balanced that thing is. I put that chain sprocket 4 washers away, so basically it'll be right up against this, which is fine. However, I did not account for a bolt going through the plate, which the all thread, and having a big nut on the back side of it. And that all thread is about 10 pounds, 8 pounds. So what I'm going to have to do is bring this all the way forward, and then that'll give me another, so that's 13/16 inch thick. Here's my glasses. So I'll need longer bolts, clearly. So 13/16. So basically I'm going to need to bring this, I'm going to need to expand the pillow, or the bushing pillows, or whatever you want to call them, away from each other to get this sprocket further away from this plate so that it'll clear that. And I need another, looks like a 1/4 inch, about 3/16. So right now it's at 3/16 clearance from that, so I need 1 1/8 away, which means I'll need some longer bolts, clearly. So, and here's why. Because obviously there's play in the bearings, right? So it's about 3/16 of an inch play on either side. And with the weights on one side and the spool of plastic wrap with the 8 to 10 pound all thread on there, with this basically sandwiched. And yeah, I could weld this to a hole and flush it, but I just don't think that this is, I don't trust that this would be a solid enough thing. So I want to drill a hole big enough diameter for the all thread to go through, and then weld this weld this nut to the back side so that I can screw this in and then tighten this down, so that I can tighten the all thread down on the front and the back nut will be welded to the back of the plate. The plastic is 12 inches. The cardboard is 12 3/4. And if I were to center that, it would clear just right. No issues. So I don't have to go any further out. I can get it basically right up to the edge and it'll clear. But it's got to be out here, obviously, so that's why this is so long. All right, I think that's going to be it for today. Thanks for watching Fabricating Firewood. Like, share, subscribe, and feel free to make any comments of what you would have done differently, or if you have any questions specific to that. I think I pretty much gave every measurement needed, and I'm going to continue to do so. We'll just see what tomorrow brings. I'm pretty tired right now. You know, I might weld those other brackets on just to stiffen it up a little bit. Just going to have a little extra weight in there. Well, thanks for watching.